calculating heat of formation or combustion. In this problem, it says calculate the enthalpy of formation of ethanol, C2H5O5. Given that the enthalpy of combustion of ethanol is negative 1,370 kilojoules. So we have the heat of formation of water and the heat of formation of carbon dioxide. So first we're going to write out the equation. So that's going to be C2H5, and it's going to be the balanced equation. So plus then 3O2 gas, so that's combustion happening, yields 2CO2 gas plus 3H2O liquid. So now that we have this, we can use what we know and understand about the heat of combustion. So this enthalpy of combustion that we have here, we can use that to calculate the heat of formation of ethanol. So we're given these two, but we need to figure out what this one is. So this heat of combustion equals the sum of the heats of formation of the products. So this symbol here stands for sum, products, minus the sum of the heat of formation of the reactants. So we can use what we know to figure out the heat of formation of C2H5O5. So what's going to happen here is we're going to replace this with negative 1,370 kilojoules equals 2 times the heat of formation of CO2. So that's going to be negative 394 kilojoules per mole. And then we're also going to add that to 3 times the heat of formation of water, which is negative 286 kilojoules per mole. So put that in parentheses here, and this has to be added together and then subtracted from the sum of the reactants here, the heat of formation. What you need to know is that the heat of formation for C2H5O5 is unknown, so we write that. But the heat of formation of oxygen gas, we would multiply that by 3. But since the heat of formation of O2 gas, because it's in its stable elemental form, is going to be 0. So we can cross that out. So now we just are left with the heat of formation of C2H5O5. So what we have to do is add these to multiply, then add these two together. And then we can use that to solve this problem and figure out what the heat of formation of C2H5O5 is. So when I rearrange and I get my variable, the heat of formation of C2H5O5 by itself, I'm going to find that the heat of formation is negative 276 kilojoules per mole for C2H5O5.